Hey guys, we're going to talk about a couple new factoring patterns that we haven't learned before, and they are the sum and difference of cubes. So we already know what sum and difference mean. A sum means we're adding, difference means we're subtracting. So if we look at on the left side where it says the sum of cubes, we have right here a cubed plus b cubed. So that means we're taking some perfect cubed a cubed, adding another perfect cubed b cubed, and we have a special pattern that factors to. And that is on the other side of the equal sign, the quantity a plus b times the quantity a squared minus ab plus b squared. So what we have to do whenever we encounter a sum of cubes or a difference of cubes is to determine what a and b are, which are what numbers are actually being cubed here, to be able to use the pattern and factor. The difference of cubes is very similar. Obviously, you can see over on the right that because it's a difference, we are subtracting. And it's just a cubed minus b cubed. The factoring pattern is very, very similar. The only change is that your first factor is a minus b. So that should be easy to remember because this is difference of cubes, whereas the sum of cubes is a plus b. And then in the trinomial that follows, they are all addition. It's the same terms as in the sum of cubes, but it's a squared plus ab plus b squared. All right, let's get started and see if we can use these. Factor each sum or difference of cubes using the appropriate factoring pattern. So letter A is x cubed plus 64. Because we are adding, we know this is a sum of cubes. So I'm going to use my pattern on the left, but the first thing I need to do is identify what a and b are. So to get x cubed, I had to cube x. So I could write that as x in parentheses cubed. To get 64, I had to cube 4. Or you could ask yourself, what is the cube root of 64? It's 4. So I could write this as x in parentheses cubed plus 4 in parentheses cubed. And that helps me identify what a and b are. So now I know my a value is x, my b value is 4. So I'm just identifying my a and my b so that I can now use my pattern. I'm just going to write my pattern with the a's and b's and then fill in our appropriate a and b for this situation. So it's a plus b times a squared minus ab plus b squared. So I'm just going to plug everything in. A plus b, that would just be x plus 4. A squared, that would be x squared. Whenever I'm doing something to my a or b value, I'm going to put it in parentheses. Okay, minus a, which is x, times b, which is 4, plus b squared, so that's 4 squared. Now, obviously, I can simplify this, and we always want to simplify as far as we can. So let's simplify what we can. The first x plus 4, nothing can be done, so that is x plus 4. But x in parentheses squared is equivalent to just x squared. And then x times 4, we would write as 4x. We're going to write minus 4x. And then 4 squared is 16, so plus 16. And this is your final answer. Using the pattern, we have factored x cubed plus 64. Let's look at letter B. Letter B is x cubed minus 27. So since we're subtracting, this is a difference of cubes, so we're going to use our pattern on the right. Let's first identify a and b. Let's write this as x in parentheses squared, and then we know the cube root of 27 is 3, so that would be 3 cubed. I realize I said x squared instead of x cubed. So x in parentheses cubed minus 3 in parentheses cubed, which helps us see that our a value is x and our b value is 3. So those are what we are going to use in our difference of cubes pattern. So let me just write that difference of cubes up here and fill in what are appropriate values. So it's a minus b, and then it's a squared plus a times b plus b squared. When I substitute in my values, that is going to be x minus 3 parentheses x squared plus x times 3 plus 3 squared. And then I'm just going to simplify what I can. I still have x minus 3 out front, but then I'm going to have x squared plus 3x plus 9. And that is a difference of cubes. Okay, let's look at letter C. 32x to the 5th minus 4x squared. Now, I hope you notice that these are not cubes. But one thing we talked about in our lesson previous to this is factoring out a greatest common monomial first. So when I look at these, I see a 32 and a 4, and I know that 4 goes into 32. I also see x to the 5th and x squared. And I could take x squared out of both of those. So my greatest common monomial would be actually 4x squared. So if I take that out of those two things, actually, let me write that in a different way so you can see what I'm doing. If I put a 4x squared out front, remember that is like we're taking both of these and dividing them by 4x squared, just to give you a little idea. So when I take 32, x to the 5th divided by 4x squared, I get 8x cubed. And then 4x squared divided by itself is just 1. So then I'm left with 4x squared times 8x cubed minus 1. And what I'm left with inside my parentheses is another difference of cubes. Now this 4x squared has to stay out front. So every time I do something, I'm going to keep that out front. So I'm just going to write that right now. Now I know 8 is a perfect cube. Its cube root is 2. So I could write this as 2, and then I have the x as well. So 2x in parentheses cubed. And 1 is actually a perfect cube as well, so that's 1 in parentheses cubed, and I'm subtracting. Now, my difference of cubes pattern, I start with, now let's see, our a is 2x and our b is 1. Remember, it's a minus b. So my first thing I'm going to write is 2x minus 1. And then the trinomial part of my factoring is a squared. So that's going to be 2x in parentheses squared plus a times b, so 2x times 1 plus b squared, so that's 1 squared. Now we have to simplify that. So 4x squared still up front, 2x minus 1, can't do anything with that. When I take 2x in parentheses squared, that's actually 4 times x squared, and then I have plus 2x plus 1. And that is a difference of cubes, but we had to factor out a greatest common monomial first. Okay, last one, x to the 4th plus 125x. I'm sure you can all see we have an x in both of these, so I'm going to need to take out an x out front. Remember, if we would divide those by x, we'd be left with x cubed plus 125. And this results in a sum of cubes, where we could rewrite this as x in parentheses cubed plus 5 in parentheses cubed. So my a value is x, my b value is 5. Sum of cubes, as we did in letter A, starts with a plus b. So I have to leave my x out front that I factored out, and then I'm going to write times x plus 5. Then it's a squared, so x in parentheses squared minus a, which is x, times b, which is 5, and then plus b, which is 5 squared. And then I write my x times x plus 5, and I simplify the items inside my trinomial. That would be x squared minus 5x plus 25. And those are some sums and differences of cubes.